The last property we're going to talk about then today is the change of base property. And this one's actually super, super powerful. Because like right now, say I asked you to find, if I asked you to find log base 5 of 140, you'd say, basically, right? You'd refuse and not really know what to do. So we're going to talk about how we're actually going to solve these problems. The way we're going to do it is through change base. So basically the change of base formula says that if I have some log base b of m, that's the same thing as log base b, or log base 10 of m over log of b. So the log base b of m is the same thing as log of m over log of b. It's also the same thing as natural log of m over natural log of b. In fact, it's the same thing as log base anything of m over log base anything of b. So the idea is, if you only had a book, which is how they used to do logs, if you only had a book of base 10 logarithms, you could find any log in the entire universe. If you only had a book of base e logarithms, you could still find any logarithm in the universe. Even if you had a log base, 13.2, as long as you had all of them, you could find any log of any base that you wanted. So for example, in this log base, try this again, in this log base 5 of 140, we've said, so the way you kind of remember which one goes on top is I kind of draw like a little squiggly line, and I think, all right, the one up here goes on top of the fraction, the one on the bottom goes on the bottom, and I can just write log out front. So the one that's kind of like, because it's 140, it's like up, so it stays on the top. This is 5, stays on the bottom. I don't know if that works for you or not, but that always works for me. But anyway, let's say that log base 5 of 140 is the same thing as log of 140 over log of 5. So you can go over here to your calculator and test it out. I say, okay, log of 140 divided by log of 5. Get 3.070. So it equals about 3.070. All right. So I'm actually going to pull this down here, so that I can have a pretty, oh no, I lost my L. And I did something funky with it. I'll just write it back in. Log. Alright, so let's try it the other way. Let's try converting it using natural logs. Log base 5 of 140 gives me, instead of writing it as log base 10, I can write it as log base e, or natural log. So natural log of 140 over natural log of 5. Now, believe it or not, I go stick this in my calculator. Natural log of 140 over the natural log of 5, I actually get 3.070. 3.070. So it's the same thing. I get it two different ways. This is where you just go, ooh, because you're supposed to be super impressed. This is actually, I hope you recognize, pretty awesome, because now you can pretty much find the log base anything of anything that you want, just using either the natural log or the common log that you've got. So you can do all sorts of fun stuff with this. And so while we're on the subject, make sure that you've got this straight. Let me go stick this in my, what's it called, list, my master list. So I'm going to need more space, I think. Log base b of m is the same thing as log of m over log of b, or natural log of m over natural log of b, or log base anything m over log base anything b. Now I want you to really take a look at this and tell me, is there anything on this list that looks like this? So stick this list in your head. In fact, I'm going to go ahead and copy them over. I know you can't do this, but you can also look at more than one sheet of paper at once, which I cannot do. Okay. you. This one. Okay. So you've got our list here of stuff. Right? List of stuff. All right. This is what we've learned today. I want you to tell me, is there anywhere on this page that teaches us how to do this? Do you see this anywhere? Even if I put a base B here. Do you see anywhere that I can do this? Anything on here at all? The answer needs to be no. In fact, the answer needs to be no with a giant exclamation point echoed twice. Okay? This log base b, or log base anything, of x plus y, just write it. I don't know what I was doing after. Is not the same thing as log base b of x plus log base b of y. It's not, right? Because log base b of x plus log base b of y... Thomas has a milk car. Just that was exciting. Sorry. We're into Thomas right now. All right, anyway, so this plus is really equal to times, right? So whenever I have pluses, I should think times, not this. This is not equal to. For the same reason, for example, that you would never say something like, oh, I don't know, you would never say, 3 plus, do it, 3 plus 4 squared. You'd never say, well, that's the same thing as 3 squared plus 4 squared. Or hopefully you never would, right? Because this is 7 squared, or 149, and this is... Wait, how about 49? I can do math, I promise. This is 9 plus 16, that's 25, right? So those are clearly not equal. Similarly, you wouldn't say, oh, the square root of 16 plus 9... You would never say that that's the same thing as the square root of 16 plus the square root of 9, right? So this would be the square root of 25 or 5. That's not the same thing as 7, right? So for the same reason you can't do that, you can't distribute a log. You can't go, oh, look, I'm going to apply the log to everything. That just doesn't make sense because it's a function. Just like everything else here, this is a function you can't distribute. This is a function you can't distribute. I'm really going to put a check mark and just talk about it. So you do want to be really, really cautious when you're dealing with logarithms because you're going to be so excited that you're like, wow, look at all this stuff I'm doing. I'm so awesome. And then you're going to do something goofy and you're going to get the problem wrong. So similarly, the same thing, log base b of x minus y, this thing, you leave them alone, right? I leave them alone. We never touch them. Peach yogurt, that's very exciting. Thank you. All right. Similarly, keep losing my train of thought, I wonder why. Say I have log of 5 over log of x. I'll call it this. How about log of x over log of 5? Is that the same thing as log of x over 5? Are these the same thing? They're not. Not the same thing, right? These aren't the same thing. Why? Because this here, this first one, is a change of base formula, right? It's this thing. It's my change of base formula. So it's like looking at my change of base formula backwards. This is really log base 5 of x. This is log of x minus log of 5. So these are not equal at all. You really want to make sure that you've got these straight. So you want to watch out with your algebra that you don't get kind of really excited because you're like making so much progress that you do something kind of goofy.